What's going on, CWC? This is another story for the spring 2024 cohort. We have the great privilege of having the presence of Mohammad Shoeybi, who I know from, we were just chatting about this 12 years ago when we worked together.
It has been a while.
12 years. When we worked together on actually writing, like building sort of an analytical enterprise software product. And I think at the time, I was at the company a little before you, Mohammed, but you did all the like algorithmic work. I remember you had like a machine, a physical machine in the office.
Yeah.
Was like specifically acquired to run like training and do the R&D. So that was, yeah, that was 12 years ago. So maybe we can just time travel from 2012 when we worked together to like now. You don't have a machine in your office. Maybe you still do.
No, I do not actually. I
do
do not
not.
have. I have my laptop, but we used to, again, in Bench, like we had this machine that had, I don't know, 12 CPUs or something on it, and we were doing training. And now what we train on is 10,000 GPUs, and each of those simulations cost millions and millions of dollars. So things have changed like over 10 years. Yeah, it's changed a lot, and it's changing really fast. Like 6 months ago is way different than
Yeah,
yeah, there are a lot of advancement happening on a weekly basis.
Bending. Yeah.
So
just for the record, for the audience too, like, so Mohammed, I think Nor1, when we were at Nor1 together, which was this enterprise software company, that was like, for you, that was after grad school. That was right out of grad school?
No, actually, I worked for another company for 2 years after grad school, and then I moved to Nor1, and
if I recall,
had the pleasure to working with you.
It was a lot of fun. I should have stayed around longer. I kind of regret leaving when I did. I think was ping pong still a big thing when you were there?
Things have changed. Definitely in those days it was big, but like I haven't played. What's that?
We moved offices, and then the ping pong table was like not a big deal.
Not really. Yeah. So
but so for grad school, you PhD in fluid dynamics, or
yeah, so
fluid mechanics, something like that.
Yeah, so my PhD, what I did for my PhD and what I'm doing right now, it has a lot of overlap, but not in terms of the applications that I was working on. So I was doing computational fluid dynamics. So they basically investigating like how fluid flows, like how to simulate fluid flows. So, but the background that I had has actually helped me a lot with respect to my career, in a sense that I did a lot of programming and algorithms, and a lot that is happening in machine learning and today's AI, as well as related to, you got to be able to program. Programming is really, really essential. And then you got to be able to analyze, and you got to be able to model and run these simulations as well. So a lot of it, though the application like fluid dynamics is very different than AI, but a lot of those knowledge or skill set are transferable.
Yep, for sure. So maybe you can characterize just a bit for the audience, like what you're doing now, in a concise, explain it to me, who, I'm like a fake data scientist at this point. I'm not a real one.
You're very humble, but
explain it to me like I'm 5 kind of thing.
Yeah. So what I'm doing right now is trying to build models that basically model the natural language. So this is very similar to, for example, the applications such as ChatGPT that probably a lot of people are familiar with. So what you're trying to do is you try to gather a lot of data and try to teach the machine how to understand this data. So like some of the work that we do, we feed the model with the amount of data that is probably thousands of years of somebody just reading 24/7. So we feed this data to the model, model understands like correlations between different pieces, what is happening. So first it learns the language, it learns the grammar. It also learns some logic as well, how to compose, how to reason slightly, like not reasoning in a mathematical sense, though it learns a little bit of that as well, but it's more like kind of how it can combine things and how it can infer things. So, and as a result of that, you have like a model that has a good understanding of the world around you, because as humans, the way mostly that we communicate is through language, and language is very, very strong feature that basically represents the way humans operate.
Yeah.
And so these are like the type of models that we're trying to build and try to also apply them to some of the applications.
So for, I think everyone in the clinicians who code community is like knows the acronym LLM.
Mhm.
I think one of the points of I don't know, friction or confusion is maybe too strong a word, but it's like there's so much terminology here. And I've tried a little bit to clarify, but I got a question from one of our members, Caleb Johnston. He asked, like, just clarifying some simple terms, like when people say AI infrastructure, how does that relate to like what you're doing versus generative AI versus LLM? Like,
Yeah.
this is definitely not apples to apples, and I think there's probably different perspectives on it. But if we just take, for example, those three terms, AI infrastructure, like if someone says this is an AI infrastructure company, what does
Yeah.
that actually mean? Versus like this is a generative AI company
Yes.
versus this is an LLM. I don't know if anyone says this is an LLM company, but like,
There are a lot of companies that are LLM companies. So one thing to clarify is acronyms and the way people use it. It's very confusing. It's confusing to me as well, as a person that works in this.
yeah,
And the reason is like different people interpret things differently, and then there is no like common or there's no consensus with respect to things. So everybody it's up for interpretation. So what I'm gonna also say is my interpretation, and I hope it has like huge overlap with what the community is also using. So let's go to the first part that you mentioned, AI infrastructure versus like a
generative.
generative AI companies. So though there is a lot of overlap, but if a person like me, like when I hear those AI infrastructure, would be companies that work on providing the tools and ecosystem that people can build their models within. Like this can be a company that provides, for example, some compute that you can use and train your model. This might be a company that provides some software that you can use to analyze or train a model, or this might be a company that provides capability for you to serve your models as well. Serving means a model you should be able to infer. You should be able to give it some data and get some data out of it as
But
well, or
once you
get
have
some
it
signals
trained,
out of it.
once you have it trained, then you
Yeah,
then serve it or host it, and it's like
or host it. Yeah.
service. It's like live and taking orders kind of thing.
Yeah. And just to put into perspective, the amount of compute and infra required for serving is actually these days is more than training, because
Whoa, really?
these models are getting a lot of traction.
Yeah.
And so you train them once, but you use them like for months and months and months. So as a result, like the amount of money is spent on training nowadays, again, it used to be different. Nowadays is less than the money that people spend on inference. As a result, you can
Very
see in the
interesting.
community that
Yeah.
there is a lot of startups, a lot of companies talk about like inference because it's a more expensive problem. And to be honest, if these models gonna be really widely used, it's very important to bring the cost of inference down. So there is from research perspective, from infrastructure perspective, even companies like NVIDIA that I'm part of, that we provide the chip as well. there is a lot of work happening just for inference,
Okay.
that to make sure the prices go down, people
Like
can use them.
accept a prompt or input, and then just run through the computation. There's no training involved. All the weights have been,
Nothing. Yep.
they're stored in memory somewhere,
Yep.
and you're just accessing them, doing compute, and then sending the response back over the network.
The
Just that.
response back. Yep. Just that. Just that. It's,
Yeah. That's fascinating to think about, like that for so long, the usage was probably like de minimis. It was all like esoteric research, right?
yep.
And so there's so much that goes into training. That's the investment, where it's like
Yep.
train millions of dollars, train, compute weights, a little bit of usage. And now it's like
It
the
exploded. Yeah.
scale hit. And that's
Yeah.
fun. It's lost heads.
Yeah, it's very interesting. Like, look at ChatGPT. It's the fastest growing application. Like, it took just 2 months to get to 100 million users. And those users, as you brought up, is like, that's not a training. That's just the model is there and they sending a prompt and getting something back. So that is basically inference. So it's all of a sudden you have like a lot of people are using it, and these models are becoming more and more popular. As a result, like serving them is the
A
I
challenge.
would say the challenge and the hot topic these days as
Yeah,
well.
maybe like the commercial focus, right? Or the economic focus. Yeah.
Definitely economic focus. Like when companies announce like, oh, we have a better model, another aspect of it, oh, look, you can now infer cheaper as well. That's also another attractive point
Yeah,
that
I
they
meant
provide.
maybe it's also because of the competition, right? Like,
Definitely. Yeah.
startup companies are, to map it back to um, the terminology question, or conceptually, right? Because language is so important here, right? If you're like AI infra, for every one AI infrastructure company, those are very capital heavy, capital intensive companies, right?
Definitely.
Whether you're developing software to help with training, or to help analyze models, or to like manage the distributed computing. I can't even imagine. There's like so much that goes into it, but it's like a lot of capital. For every one of those, there's probably 10,000 companies that would brand themselves generative AI companies that
Definitely. Yeah.
are using a model. So it's already been trained. Someone else has done the work to train it on the massive data sets, invested those millions or tens of millions or hundreds of millions of dollars in capital, and maybe even put the model on Hugging Face, right? And then you can come as an entrepreneur and be a generative AI company by taking that model and then doing inference. Or maybe this thing. So another question we got was around fine tuning.
Yep.
And like this concept of tuning, like this pre-trained, obviously GPT, pre-trained transformer, but then like you can train after. So like the fine tuning part, do you get like a little more cachet or like street cred if you like take a model and then you fine tune it and then do inference? Like what is the difference in terms of like getting performance? If you want to get performance out of one of these models, and one way to do it is like to give good prompts and have right context. Maybe do
Definitely. Yeah.
this RAG, the retrieval augmented thing, just better prompts, right? Use the context available to you in the most strategic way. But then there's also this fine tuning thing where you can update the weights after. So how should we think about those in terms of
Yeah.
tools?
Yeah, those are all good questions. So one thing is with respect to toolings around it, you can look at it as like App Store and the Google App Store or Apple App Store. It's like you build apps on top of this. So
Yeah.
there is actually like you can build a lot of applications on top of it and use the backbone. Like, yeah, I mean, if your phone is the backbone, now your model and API is the backbone that you build on top of that.
Yeah.
So with respect to, sorry, go ahead.
No, I just confirming. I mean,
Yeah,
that definitely resonates. I remember having this feeling of like, it's funny, my first experience with the models was pretty sort of trivial, and I think unoriginal, right? That's to write a poem, this other thing, right? And then this is with GPT 3.5. And then I gave it some heavier data analysis tasks to complete some statistics, and then I forget who it was that recommended this, but they're like, ask it to give you the response in a structured, computable format, like not just plain language, but like ask it for JSON and give it the schema, and
Or a
then
SQL, you can give it natural language and it
yeah,
writes for you SQL. You can query your database.
totally. And so then like this thing was switch flip. I was like, whoa, this is like an anything API. It's an API for anything.
Yep, definitely. Like you can use it again. You go through programming. We use it like in general. Like we use it for programming. You can ask it to write function. You can ask it to write the code. You can give it the code and you say rewrite it. So there are a lot of applications on top of it. And I feel like this is the beginning. Right now, we as the community or community is trying to figure out to make these models better. At the same time, there is an explosion of like what you can do with these models. You know, it's like how it's trained, what it is, and all those is one thing that we're trying to figure out, but it's like how you can use it and how you can make it reliable as well. You point out hallucination, another aspect, you point out RAG as well. So all of these, like for example, let's say you are uh, you have some medical report from your patients or some of the things that you don't want to share. You know, these are like super sensitive. So you don't want to train a generic model with that, versus you can get a model, find like a model that has been trained on the entire web and everything. It knows language and all those, but it doesn't know anything about your proprietary data. So you can fine tune it and teach it like, oh, this data exists. And then the model knows that your data knows about your data, and then it can infer it. Or you can use it, as you said, retrieval augmentation. You can basically bring some of the information, like let's say past history of a patient, you put it into the prompt. So the model analyzes it, the model understands it, and then you can interact with it, like has suggestions, summarize it, have ask questions or other things as well. So you can use it in multiple aspects. So I think it's very important, like not everything needs to go into pre-training for a lot of different reasons. Most importantly is like every person, every company, every group has their own proprietary data, and model doesn't know about those. The other aspect of it is also you want to have like customizability. Like for example, again, I'm talking about ChatGPT because it's most well known. This is a generic model. This is a model that is designed to be good for the entire universe. But as a result of it, you make sacrifices. It might not be as good for finance. You know, if you have finance data or if you have healthcare data in a specific, if you fine tune it, it's going to be better for finance. And if I'm going to use it for finance, I don't care about, I don't know, some other things. I don't care if it's going to write a poem for me. You know, it's just
or know a visual modality, be able to work
or
with.
visual modality. Yeah, so there's actually visual modality. So I know I'm talking a lot about text, but generative AI has all the aspects of it. So there are 3 or 4 modes. There is like the text, there's image slash video, and there's audio. And a lot of models or capabilities come in now. If you look at, for example, OpenAI released GPT 4.0, Gemini from Google,
Yep.
some other companies, you have all the modes together. So you can go from any mode to anything. It can take it, it can generate video, it can generate audio, or it can take audio and all those, combine them together in a unified way. So you don't need to have a lot of different things combined together and different pipelines and process them. So it gives you an API, just give it whatever you want, and then you will get whatever you want. So you can actually use it and build on top of it as well.
There's a question I want to relay that has to do with this concept of like a scope of a model, right? Because I think for a lot of folks, there's still like I think the scale and the complexity of these models is difficult to grasp.
Yep.
And like the idea of like, you were using the language of you do have to make sacrifices. And if you want a general model, right, then you are going to make sacrifices. And you can get specialized, but it's like not it's different than like a sort of traditional, let's say, parametric approach of like
Definitely. Yeah.
Yeah, having to define a specific support of data, right?
Yeah.
So before we get to that, I want to sort of tie back to this. So the models, the AI infrastructure companies that are like building models and training on data and like in some way part of the supply chain or the ecosystem of how to do the training and evaluate them and get to something that's like then ready to serve, let's say. After that, you have these other companies, and I think your example of like having sensitive data that are in medical record systems or folks' personal, information. It's like, well, yeah, the models were not pre-trained on that. They kind of can't be. And so there's like a couple different approaches to then enhance the model or get better results in using that data. The smallest, and this is my sort of naive way of thinking about it, seems like the smallest is just like included in a prompt, right? It has to fit inside this context window. Prompts can't be infinitely large. They have a specific known finite amount of data that can be added in a prompt.
Yeah.
And then
I just want to add to that, sorry to interrupt you. Like, this is another area. Like, past year and a half, there has been, like, we started from models that their prompts with 2,000 words. Okay. This was very common last year. This year, we're talking about 1 million words in the prompt.
little difference.
A little bit different. So I wanted to pause here. It's like I said, like this goes really like over a year, we went from 2,000 like 50 times larger to like 1 million. Like basically you can fit the 5 books in it, and then it can attend and read it and based on that generate results. So things are changing.
in some sense, like that makes right, because I would you assess this as an accurate statement that retrieval augmentation is sort of just a way of being clever of dealing with the constraints of a small context window?
Definitely. So that's one way of looking at it. The other aspect of it, again, I super simplified it, is the cost as well. Like for example, when you read a book, when I ask you a question from the book, you don't read the book fully and answer it. You go to that section and answer it.
Yeah, this is like indexing versus a table scan in a relationship.
Yeah, exactly. So as a result, like the amount of compute you're gonna spend if you just take that page or chapter and try to answer it versus feed the model the whole book, it's gonna be very expensive. You can still feed it the whole book and get the response, but then the retrieval gives you, look, just feed it this 5 page and then get the results, and the answer is going to be the same because the answer is there. So that's part of it that retrieval augmentation helps, is with the cost.
Yeah,
Yeah,
cost.
cost of it. The other thing is also when you go to enterprises, is like 1 million word is nothing. You're talking about petabytes and petabytes of data. That is infeasible to feed it to the language.
For sure.
So there are all use cases of this, but it's also like, again, if you look at last year versus this year, is people think about retrieval augmentation is slightly different because models are becoming more capable.
Yeah.
Like how much I should retrieve, how much I should just put it in the prompt and like
Yeah.
lazily ask model just to interpret it for me.
So, and then there's this fine-tuning approach, and this like reinforcement learning with human feedback concept. So these are also ways to try to get better performance out of, what you might quote unquote foundation model, or like, which I think it sort of intuitively makes sense to call it that. But like, how should we think about? Well, I'll try and ask like a clear question so that we can go from there. But like, is one strictly better? Is one approach strictly better? Or do you anticipate that one will emerge as like, oh, well, yeah, you should always fine tune models kind of thing, or under XYZ conditions, it always makes sense to fine tune a model? Or do you believe it's like, well, no, it really does depend. They're all tools in the tool chain, and you have to pick what approach you want to take to try and get good results from the models.
Yeah, exactly. It's the latter. So, but by the way, part of human feedback as well, reinforcement is part of it is fine tuning.
Yeah.
Fine tuning in a specific way. So what reinforcement learning with human feedback does is when you train a model, the model is basically representative of the world, but it just knows representative of it doesn't follow instructions. It doesn't it just knows language. It's not knows the word, but it doesn't know instructions. So what you're trying to do is push it in the direction. You're not changing the knowledge of the model. You just teach the model to follow instruction. Like when you give it, hey, write a poem in this way for me. It's just you're teaching it. It knows how to do it. It is in a statistical model. It's just you say it, okay, sample it this way for me.
Right.
So when you fine tune as well, fine tuning, you basically add knowledge or store knowledge in your model weight parameters, basically, or the parameters of the model. So, and as you brought up, I mean, these are different methodologies, and there is no one size fit all, So, and that's part of it. Like you got to look at and see like what you want to do, how you want to do it as well, and what you have access to. Like, for example, are you just going to use OpenAI models, or you have a model that you download from Hugging Face that you have access to all of it and you can do surgery on the weights and apply them. So it really depends on what you have available. And it's also how much data you have available. If you have 10 samples, please don't do fine tuning. You're not going to get anywhere. If you have million samples, then it's a lot different, then you can fine tune, you can adjust it. So it's very different case by case.
Is that threshold like a relative scale where, if you have n observations going into the pre-training, you need some proportion of n in fine tuning to get real results, or is it actually sort of not that kind of structure of relationship? It's more an absolute count actually, and if you can just get a certain number.
No, it's actually there are relationship, but it's more like kind of with respect to your model fidelity, how big is your model? Okay. So the larger the model is, the more sample you require to make a huge difference,
Makes sense.
But for a smaller model, as you have a smaller number of samples that you can make a huge difference. Like for example, if you go extreme, if you have logistic regression, which basically you have the first layer, it's like you need a lot less samples to adjust the model, because versus if you have like a gigantic 100 billion parameter model, then the trade-off change.
For sure. Yeah. And is that like the best measure to characterize the size of a model, like the number of parameters it has?
That's so we got to be careful with respect to, again, I don't want to get too technical here, but as long as the model is dense and it's not sparse, then the size of the model, number of parameters, those are the weights that can adjust. So basically that's the capacity of your model.
Yeah.
Like you have one, but yeah. So that basically shows the power of the model.
So holding fixed sparsity or density, like holding that constant, then weights are a good, or number of parameters is a good characterization.
It's a very good indication of how capable your model is and also how expensive your model is, both training and also inference as well.
Yeah. So I expect for the community here, like most folks are just kind of, that they're manually prompting, very likely one of the three, either Claude or Gemini or GPT or something.
Yeah.
And then for a subset, I think it's important to know like maybe one sort of direction or area for growth or learning would be like learn more about fine tuning. It's important, actually.
Definitely.
Yeah. And I think specifically in healthcare, where there is data that's not the pre-trained model is not privy to, it's never seen. That as long as there's sufficient volume of that data and that the data is like high quality, and by high quality I mean like actually contains a lot of information. It's not just
definitely
same data repeated over and over and over again. right?
Yeah, I just want to add to your point. Look, um, I don't have a statistics, but I'm pretty sure there is a lot more proprietary data than public data. And
Mm,
these models typically are trained or public data or data that you don't need to pay for, because a lot of companies don't share data. So as a result, like these models don't know as much as like they don't know the word, because there's a lot of proprietary data. So as a result, fine tuning is very important, you know.
yeah,
And you don't need to like learn things from scratch. So like, for example, through your proprietary data, you don't need to learn English grammar. So English grammar you can learn through web. So you can train it and have that, but then you can fine tune it on your data so it knows about it. It has the know-hows of your data or your system.
for sure. Very cool. Very cool. The so the let me get to a couple more questions here. I want to it's late at night for the CWC here, just to like give extra appreciation to Mohammed for spending time with us here with a
Of course, yeah, it's my
very, very,
pleasure.
very young newborn at home, and spending time late at night to talk about this stuff is pretty awesome. So Kevin Shaw from our community's pharmacist, he asks, I think a really good and simple question. It's a bit of a rehash of what we talked about, but I'd love just like your concise take on it, which is, what's the best way to practice prompting?
Yeah.
Like, so if we interpret that, I guess interpreting, if I put it through my filter, it's like, how can I get better at getting results through prompting? Is there anything better than just kind of trial and error, right?
I'm gonna give a very disappointing answer to it. And to be honest, no. So one thing I want to add is models are getting a lot better at being less dependent on the prompt. And again, part of reinforcement learning with human feedback is actually the goal of it is this. Like when you go through like the fine tuning or the process, like for a specific answer, you have multiple forms of prompts, multiple the way to ask it, what to ask, and all those. And there's a lot of that's also, by the way, another line of really good work. There's a lot of annotation happening by individuals as well. So they're trying to make the model a lot more independent on the way you prompt it.
So
So
annotation,
as a result,
just to pause you there, is annotation's this reinforcement learning with human feedback?
yes. So there's a lot of data that is collected through that.
Right.
So this is actually like you have, and there is millions and millions and hundreds of millions of dollars being spent just to collect these type of data.
And
So you put,
that's used to like update the weights according to some kind of cost function.
definitely. That's according to a cost function, and that cost function again comes from human preference.
Right.
So
right.
like, for example, one way of doing it is like you say, this is the prompt, and then you prompt the language model and you have 10 different generations. By the way, one thing is like when you prompt a model, you can have it to generate different things. You know, it's not like every time it's going to generate the same. So you, for example, generate 10 different, and then you show it to humans, and the human says like A is better than B, than C, than D. And then the model knows, okay, this is human preference. This is where the
I
human
think
preference come from.
probably everyone in the community has had that experience with ChatGPT, where every now and then it will offer you two and it will ask you to pick which one.
Yeah, definitely.
You're getting
Yep. They're
one of
getting it live from feedback from people for free. So
that.
that's a definitely good way of it. So as a result of it, again, if you look at it, like 2 years ago, they call it prompt engineering, was a lot more important than today. Again, still prompt engineering, still is important how you prompt it, but models are getting better and better and
They're
better.
kind
So
of
as a result,
automating away, or
definitely automating, because it's a pain. I mean, the whole point of it is automation. The whole point of it, the model to be generic. So if you need to know how to prompt it is actually is a weakness from model. So the short answer is at this point is at least I don't know a better way of doing it outside of like you play with the model and you understand the model. You build a relationship with model and then you understand how you prompt it and how does it know. But I can assure you, like if you try something today and if you try something in 6 months, a newer version of a model, you will see that it's going to be a lot more robust to the way you prompt it. So it would be less sensitive. So as a result, like I envision like these models become really robust. As a result, the prompt engineering would be less and less a critical aspect of to get good results.
We have another community member, who's a pediatric ICU physician. And I've actually had the chance to meet her in some office hours. I squeeze in office hours, whenever I can to try and, it's a very impressive group of people. But she asks, her name's Aida Rutledge. She asks, are hallucinations a feature or a bug? If hallucinating is a bug, like how is it fixed? If it's a feature, how do we use it so that it's not necessarily a negative?
Yeah, it's not a feature, it's an issue. It's definitely an issue. And it's a very important issue as well, in a sense that if this is my belief, like cost is one aspect that these models, like if LLMs and generative models are going to be widely used, three things needs to be addressed. One is their cost. I think they're still expensive. The cost needs, again, wide adoption. There is huge adoption right now, but wide adoption. What's that?
Cost
Sorry,
to serve or
cost to serve, yes. Cost like the amount like you need to pay OpenAI or the amount you need to pay Google or Anthropic for cloud. So that is one aspect of it. Second aspect of it, hallucination needs to get resolved. Resolve again is also, it's not going to be 100%. These are statistical models, they always make mistake, but it should be at the acceptable threshold. And the third aspect of it is there should be some way of not generating fake information, because with these models you can generate million articles a day. So these are trained. So the reason I'm saying is hallucination is a really important issue with the models. There is a lot of work happening. So for example, again, the reinforcement learning with human feedback is actually one way, again, the way you collect data to reduce hallucination. There is retrieval augmentation is another way, so you can ground your answer into documents as well, and at least provide, for example, references. So your model can say, look, I am giving this answer based on this reference, and then user can check and say like, okay, it makes sense or not. And there is a lot of good research happening in this, but as far as I know, there is no good solution, but models are getting better and better. The good thing is this is an important issue in the community. And a lot of good groups and very strong groups are working on it. So hallucination is an issue. Don't take the result of these models like with a black box. Like you gotta always check them. Yeah, and the good or bad things is the generations and the results are so fluid and good that you get convinced. So you got to be careful. These models are amazing, and they generate things that you don't find inconsistency. You got to go always like to like a database or something to check the factual aspects of it, because they might mix things up. Yep.
Yeah. So interestingly, we have at my company Canvas, we've been using different models, different services, to check one another.
It's a very, very smart idea.
And typically, like what we've been using this for is to like generate. We have an SDK in Python, and so we're like generating Python code that uses the SDK, and we check the code from other models. We also run it against test cases in an actual runtime, and then we
Mhm.
feed errors back in. So we like have a, I feel like this is an example where, and we do see hallucinations. Sometimes the system will hallucinate a method on a class. It's like the SDK doesn't have that method. It just
Yeah.
doesn't. They'll just make it
Yep.
up. And but then we catch it in running the code in the runtime and then feed the error back. And so this is an example of like a strategy. It's not a mathematical thing, it's just an approach to the problem that builds in some safety against the hallucination. And because that's
Yeah.
it, people may not really appreciate, like, the models are not useful only as humans consuming their raw output, right? They can be
Yep.
used in much broader positions in the value chain, so to speak,
Oh,
right?
definitely. Yep.
You
Yep.
can use it to generate. We do this too. We generate test data with the models. We generate the code, we generate the test data, and we're able to use that to sort of develop faster. So it's
Yep.
not always just the case of like a human being prompting and then getting a response, and then being sort of vulnerable to
No.
deception or the hallucination, right? There's
No, definitely. Like, let me give you an example. We actually use these models to generate data to train other models. We do
yeah,
that. This is a very common practice that we do. So it's not like, I mean, hallucination is a problem for specific things. For a lot of other things, these models are very accurate. You know, they're 95% accurate. But then if you have an application that 5% is important, you got to check it. You know,
yep, for
it
sure.
can happen. Yeah.
So let me, it's getting very late here. I have one one last actual question and then a little uh closeout question. But for healthcare in particular, you have doctors in the family, um, medical doctors. I mean, you're a different kind of doctor, but do you have an intuition or a perspective on like kind of what's ahead, or how these models should be used, where the opportunity is, whether it's in, and to add a little structure to the question, right? They're being used to discover or to attempt to discover new drugs, to attempt to discover new applications of existing drugs, uh, which is like kind of high up in the value chain of healthcare. They're being used to, some folks will pick a role. We'll replace nurses. We'll replace therapists. You have an AI therapist you interact with.
Yeah.
Replace the diagnostic process or replace the therapeutic process. I think, just like widespread adoption or utilization of LLMs is subject to cost constraints. Same thing could be said of American healthcare services, right? It is just so
Yeah.
expensive and it's so hard to access it. So yeah, I'm curious if you have a perspective on this, or even just a general sense of like confidence or optimism or fear in
Yeah.
any particular area as well.
Yeah. So I don't know if I'm knowledgeable enough to comment on specifics, but in terms of general things is, look, again, AI is also a very generic term, and I don't like to use it, but I think it's a good starting point. The way like these generative models, LLMs, look, they're here, they're delivering value, things are changing. Things are definitely changing. And changing in a good direction. It's definitely changing in a good direction. Like, cars are great. Cars are also really good. But also car, if a driver is drunk, is a really bad weapon. It's
For sure.
very dangerous. So, but it doesn't mean like if there is one drunk driver, we should not use cars. And the same thing, like I think these models are changing. There is a lot of automation is happening. I maybe I'm naive, but I'm not afraid of replacing humans. These are going to be assisting humans, and this is going to be. I think the value that is going to be delivered is increasing productivity.
Yeah.
That is the value that is going to be delivered. Like a lot of things that very simple. I mean, this is not AI. Like instead of like people used to type, now you can just speak and then it gets transcribed. This is very simple. A lot of things like things are going to get simplified. People are going to have help. People are going to have, like, for example, I can see, like, based on some notes or based on some inputs, an AI model will have some recommendation for the doctor. But I still think like the doctor is going to make the final decision. But the doctor is going to have a lot more tools available to them.
Yeah.
Or a writer, like still like the person that is going to write on New York Times, they're gonna make the final call, but they're gonna have a lot of good tools. A programmer still gonna have the final code, but they're gonna 70% of their code, they don't need, like we used to do a Stack Overflow, and what is happening is just gonna be automated and generated. But we still need programmer, we still have doctors, we still have like doctors in the loop, programmers in the loop. It's just gonna be increasing productivity. And it's happening in programming. Like if you talk to people that use Copilot or other things, they say like my program, my throughput has increased by 50%, 20, 30%, but it's still that person is there. So I feel like a lot of automation, a lot of like increase in the productivity is going to happen, and people's life is going to be get much easier. Having said that, is also I know a lot of people in your audience as well hear about the fears of AI. Fears are there. I personally, this is my belief, is the fear shouldn't prevent the advancement to happen. I think we should educate ourselves and try to build tools as well just to safeguard things, rather than try like to be scared of like, oh, something is going to take over. We got to look at it as like, okay, we're going to have driving rules. If you're drunk and you drive, then you're not going to be able to drive again.
Yeah.
It's like with things like that. And we
have
will have accidents. We will have accidents.
Yes, sure. And I think, it is, and a lot of people say this, I think because it's true, is like the technology is neither good nor bad inherently. It's how it's used.
Yeah.
And,
Yeah, definitely.
I had my first, I don't know if you've ridden in an AV, autonomous vehicle yet. Um, I took one.
I have not.
I took one on Tuesday morning, my first ride ever.
Oh.
We did, the boys came out on the porch, and the app was like, okay, it's 1 minute away. We all rushed down. My wife got out her phone and videoed it pulling up. The boys were so excited, right?
Oh no.
And it got in. I took a ride downtown, 30-minute drive down by the Fair Building. And it was amazing. I mean, you think about a world where like not everyone needs a car, and you have this shared, and the utilization of those cars
It's amazing.
should be like an aircraft. We don't all have our own aircrafts. That's insane, right? You want to have a very well designed, very safe machine that has very high utilization, and then we all don't have to worry about the maintenance costs of like having an airplane and the storage and all that stuff. And so like, I think in terms of medicine, you think about like quality and throughput, which I don't think necessarily any one person loves thinking about themselves that way. But even for you and me and folks in technology, yeah, we got to produce, and you want it to be high quality, and you want to produce a lot, right? And it's like,
Yeah.
in medicine, that's also true. We want really high quality experiences for patients. We want high quality diagnostic decisions, high quality therapeutic interventions, and we want to do it at scale. And I think there's an opportunity to use the models to get both and sort of make the trade-off not as sharp, right? So it's right now, it's a very sharp trade-off. You can get more scale, quality is going to suffer, right? Or you can really have concierge care, but it's going to be a really small population of patients that get that benefit. My last question for you, since is so late, is how are you using AI these days? Yeah, what's your number one use case in terms of frequency in your life right now?
Number one use case.
I'll give you mine. You ready? You ready for this?
Sure, yeah.
Before we started recording, we were talking about our kids. I use ChatGPT to write bedtime stories. That
Oh,
is
nice.
outside, and I put my oftentimes there's like a moral that I try and work in there that's like, for my older boy, he's in first grade going to second, like if something happens at school or I sense something, I'm like, okay, I'm gonna tell a story about resilience, or we're gonna tell a story about forgiveness. And I'll kind of work that in there, and I can put it in the context of things he cares about, like adventure or baseball or whatever. And I don't have to do, I mean, I just feel like I couldn't otherwise do that. I couldn't just make up a story on the fly with like a moral. But man, I do this every day, almost every day. I would say
Oh,
five nights a week. So I think personally,
that's
that's my number one use case.
that's quite interesting. Mine is going to be a little bit less exciting. I definitely use it for work,
Like
for programming,
place
definitely.
programming.
Yeah, programming. Then that's something that I use possibly the most. I also use it sometimes for emails.
I thought you were going to say to text your wife back.
Yeah, that's actually not bad. Well, you give it again, you give it the history of conversation and it can customize it to you. So
Yeah, could be tricky. That reminds me of the Silicon Valley
yeah.
episode with the. Do you remember when? Did you see Silicon Valley? The
Yes, I did.
Dinesh and Guilfoyle, the rivalry, and then like
Yep.
Dinesh chatting with Guilfoyle, or he thinks he is, but then he sees.
Yeah, and then he is, yeah.
Yeah, dicey man.
Yeah,
That is playing with fire. That's drunk driver territory in terms of how
yeah,
to.
you gotta be careful, especially if it hallucinates, then you might
Yeah,
get into trouble.
big, awesome, Mohammed. Thank you so much
Okay.
for being so generous.
Of course, yeah, it was really good, good chatting with you, talking to you, and I'm really glad that you're doing this. So
Yeah.
it's
It's
amazing.
been
Yeah,
it's been a lot of fun. It's a great community, and like thank you for contributing to it. And
of course, anytime.
yeah, and I'll
If
look
there is
forward.
anything I can help with, just let me know.
I appreciate it, Mohammed. All right, man. Have
Of
a good
course.
night.
Okay. Well, you too. Thank you. Take care.